Introduction. In our earlier classes, we have studied about the fractions and their addition and subtraction. In this chapter, we will study about comparisons of fraction, their addition, subtraction, and graphical representation of fractions, etc. Fraction. We can define fraction in three different ways. A. Fraction as a part of whole. Divide a circle into 4 equal parts by drawing 2 diameters of the circle. Then shaded parts represent different fractions. 1 part shaded 1 by 4. 2 parts shaded 2 by 4. 3 parts shaded 3 by 4. 4 parts shaded or whole 4 by 4 is equal to 1. Thus, fraction is defined as fraction is equal to numerator by denominator. Example. Suppose one chocolate is distributed among 5 friends, then each one will get 1 by 5 of the chocolate and 1 is the numerator and 5 is the denominator in the fraction 1 by 5. B. Fraction as a part of a group. In the above example, we divided a single thing among 5 friends, but the whole may be taken as a group of objects and fraction can be associated to that. That is equal to 2 by 6 or 1 by 3. Is equal to 3 by 9 or 1 by 3. C. Fraction as a part of division. We can write 3 divided by 4 as 3 divided by 4 or 3 by 4, where 3 by 4 represents a fraction. Similarly, 5 by 7 means 5 divided by 7. Example 1. What fraction of a day is 8 hours? Solution. Total number of hours in a day is equal to 24. So, 8 hours is 8 by 24 of a day or 1 by 3 of a day. Thus, 8 hours is 1 by 3 of a day. Example 2. Rohan had 30 apples with him. He gave 20 of them to his elder brother Rajat. What fraction of apples is left with him? Solution. Number of apples Rohan had is equal to 30. Number of apples he gave to his brother is equal to 20. Apples left with him is equal to 10. Fraction of apples left is equal to 10 by 30 or 1 by 3. Example 3. A bag contains 10 white, 4 red and 3 black balls. Find the fraction of A. White balls, B. Black balls and C. Red balls. Solution. Total number of balls are 10 plus 4 plus 3 is equal to 17. A. Fraction of white balls is equal to 10 by 17. B. Fraction of black balls is equal to 3 by 17. C. Fraction of red balls is equal to 4 by 17. Types of fractions. Fraction are of 3 types. A. Proper fraction. A fraction whose numerator is less than the denominator is called a proper fraction. A proper fraction is always less than a whole. Example. 5 by 7, 3 by 5, 2 by 9, etc. B. Improper fraction. A fraction whose numerator is greater than the denominator is called an improper fraction. An improper fraction is always greater than a whole. Example. 3 by 2, 5 by 3, 9 by 4, etc. C. Unit fraction. Fractions with numerator 1 are called unit fractions. Example. 1 by 4, 1 by 7, 1 by 9, etc. Representation of fractions on number line. We have learnt the representation of integers -4, -3, -2, -1, 0, 1 and so on, etc. on number line. We will now learn the representation of fractions on number line. Draw a number line. Consider various proper fractions, namely 1 by 2, 1 by 3, 1 by 4, 2 by 3, 3 by 4, etc. Each of them is greater than 0 and less than 1. So, each one of them lies between 0 and 1. we draw a number line and mark 2 points on it and name them as 0 and 1. To show 1 by 2 on number line, we divide the gap between 0 and 1 into 2 equal parts, and then one part is 1 by 2. To represent 1 by 3 on number line, we divide the gap between 0 and 1 into 3 equal parts. Then OC is equal to 1 or 3 by 3. OA is equal to AB, which is equal to BC, which is equal to 1 by 3. And OB is equal to OA plus AB, which is equal to 1 by 3 plus 1 by 3, which is equal to 2 by 3. Similarly, to represent 3 by 7, we will divide the gap between 0 and 1 into 7 equal parts, and each equal part is 1 by 7, and 3 such equal parts will be 1 by 7 plus 1 by 7 plus 1 by 7, which is equal to 3 by 7. That is representation of mixed fractions. Let us draw a number line and represent 1 and 1 by 3 or 5 and 2 by 5 on it. We know that 1 and 1 by 3 lies between 1 and 2. So, divide the gap between 1 and 2 into 3 equal parts. The first part represent 1 and 1 by 3. Similarly, to represent 5 and 2 by 5 on number line, we will divide the gap between 5 and 6 into 5 equal parts, and the second part will represent 5 and 2 by 5. Example 1. Fill box with greater than, less than or equal to. A. 1 by 2 blank 1. B. 3 by 5 blank 1. C. 1 blank 7 by 8. D. 8 by 5 blank 1. Solution. A. 1 by 2 is less than 1 because numerator is less than denominator. B. 3 by 5 is less than 1 because numerator is less than denominator. C. 1 is greater than 7 by 8 because numerator is less than denominator. D. 8 by 5 is greater than 1 because numerator is greater than denominator. Example 2. Represent 3 and 1 by 5 and 4 and 3 by 5 on number line. Solution. A. Draw a number line. B. Divide the gap between 3 and 4 in 5 equal parts and 4 and 5 in 5 equal parts. C. The first part between 3 and 4 represents 3 and 1 by 5. And third part between 4 and 5 represents 4 and 3 by 5. Mixed numbers. A mixed fraction has a combination of a whole and a proper fraction. Example, 2 and 3 by 4, 5 and 1 by 5, etc. are mixed fractions. 2 and 3 by 4 can be shown diagrammatically as follows. 3 and 1 by 5 can be shown diagrammatically as follows. Conversion of mixed fraction into improper fraction and vice versa. We can convert a mixed fraction into improper fraction as follows. Example, in 2 and 3 by 4, A. Multiply the whole number by the denominator of fractional part, that is 2 multiplied by 4 is equal to 8. B. Add the numerator of the fractional part to the product obtained in the above step, that is 3 plus 8, which is equal to 11. C. Write the sum obtained in step B in the numerator of the required fraction 11 as numerator. D. The denominator is the same as that of the fractional part. 11 by 4 is the improper fraction. Mixed number is equal to, in the brackets, whole into denominator plus numerator by denominator. Example, convert the following mixed fraction into improper fraction. A. 2 and 1 by 7. B. 3 and 5 by 7. Solution. A. 2 and 1 by 7 is equal to, in the brackets, 2 multiplied by 7 plus 1 by 7, which is equal to 15 by 7. B. 3 and 5 by 7 is equal to, in the brackets, 3 multiplied by 7 plus 5 by 7, which is equal to 26 by 7. Conversion of improper fraction into mixed fraction. We can convert improper fraction into mixed fraction as follows. Example, in 4 by 3, A. Divide the numerator by denominator. 4 divided by 3. B. Write quotient as a whole number 1. C. Write the remainder as the numerator of the fractional part and the denominator of the improper fraction as the denominator of the fractional part. 1 and 1 by 3. Mixed number is equal to quotient and remainder by divisor. Example. Convert the following as mixed fraction. A. 13 by 2. B. 17 by 5. Solution. A. 13 by 2 is equal to 6 and 1 by 2. B. 17 by 5 is equal to 3 and 2 by 5. Procedure to find equivalent fractions of a given fraction. To find an equivalent fraction, we multiply or divide the numerator and denominator by same non-zero number. Example 1. Find 5 fractions equivalent to 3 by 5. Solution. 3 into 2 by 5 into 2. 3 into 3 by 5 into 3. 3 into 4 by 5 into 4. 3 into 5 by 5 into 5. 3 into 6 by 5 into 6. Or 6 by 10. 9 by 15, 12 by 20, 15 by 25, 18 by 30 are 5 equivalent fractions to 3 by 5. Example 2. Find an equivalent fraction of 2 by 3 having denominator equal to 27. Solution. Since 27 divided by 3 is equal to 9, so to find an equivalent fraction of 2 by 3 having denominator 27, we multiply the numerator and denominator of 2 by 3 by 9. Therefore, 2 by 3 is equal to 2 into 9 by 3 into 9, which is equal to 18 by 27. Example 3. Fill up blank with appropriate numeral. 3 by 4 is equal to 21 by blank. Solution. Since 21 divided by 3 is equal to 7, so multiply numerator and denominator of 3 by 4 by 7. 3 by 4 is equal to 3 into 7 by 4 into 7, which is equal to 21 by 28. Therefore, the required number is 28. Like fractions. The fractions with the same denominator are called like fractions. Example, 5 by 15, 3 by 15, 7 by 15 are like fractions as they have same denominator. Unlike fractions. The fractions with different denominators are called unlike fractions. Example, 2 by 3, 5 by 7, 9 by 13, etc. are unlike fractions. Conversion of unlike fraction into equivalent like fractions. Two unlike fractions can be converted into two equivalent like fractions using the concept of equivalent fractions. Example, convert the given unlike fractions into equivalent like fractions. 4 by 5, 7 by 9. Solution, 4 by 5 and 7 by 9 are unlike fractions. LCM of 5 and 9 is equal to 45. 4 by 5 is equal to blank by 45. And 4 into 9 by 5 into 9 is equal to 36 by 45. And 7 into 5 by 9 into 5 is equal to 35 by 45. Hence, the given unlike fractions are converted into like fractions is equal to 36 by 45 and 35 by 45. Comparison of fractions. Example 1. Compare 2 by 7 and 3 by 4. Solution. 2 by 7 and 3 by 4. By cross multiplication, we see that which implies that 2 into 4 and 3 into 7 or 8 and 21. Since 8 is less than 21, so 2 by 7 is less than 3 by 4. Note: for comparing a mixed fraction with an improper fraction or two mixed fractions, first convert the mixed fraction into improper fraction and then compare as we compare two fractions. Example 2. Compare 4 and 1 by 3 and 11 by 5. Solution: 4 and 1 by 3 is equal to 13 by 3, as 4 into 3 plus 1 by 3. Now let us compare 11 by 5 and 13 by 3. By cross multiplication method, 11 into 3 and 13 into 5 or 33 and 65. Since 33 is less than 65, so 11 by 5 is less than 13 by 3 or 11 by 5 is less than 4 and 1 by 3. Example 3. In a class A of 25 students, 20 passed in first class. In another class B of 30 students, 24 passed in first class. In which class was a greater fraction of students getting first class? Solution: in class A, fraction of students getting first class is equal to 20 by 25, which is equal to 4 by 5. In class B, fraction of students getting first class is equal to 24 by 30, which is equal to 4 by 5. So, both the classes have same fraction of students getting first class. Example 4. Are the following fractions equivalent? 5 by 9 and 4 by 7. Solution: 5 by 9 and 4 by 7. LCM of 9 and 7 is 63. 5 into 7 by 9 into 7 is equal to 35 by 63. And 4 into 9 by 7 into 9 is equal to 36 by 63. Since 35 by 63 is not equal to 36 by 63. So, 5 by 9 and 4 by 7 are not equivalent. 5 by 9 is not equal to 4 by 7. Addition and subtraction of fractions. Addition or subtraction of like fractions. The sum or difference of two or more like fractions can be obtained as follows. Step 1. Add or subtract the numerators. Step 2. Write the common denominator. Step 3. Write the fraction as sum or difference of numerator by common denominator. Example 1. Add 5 by 11 plus 2 by 11. Solution: sum of numerators is equal to 5 plus 2, which is equal to 7. Common denominator is equal to 11. Fraction is equal to 7 by 11. Thus, 5 by 11 plus 2 by 11 is equal to 7 by 11. Example 2. Subtract 3 by 7 from 5 by 7. Solution: difference of numerators is equal to 5 minus 3, which is equal to 2. Common denominator is equal to 7. Fraction is equal to 2 by 7. Thus, 5 by 7 minus 3 by 7 is equal to 2 by 7. Addition and subtraction of unlike fractions. To add or subtract unlike fractions, we first convert unlike fractions into equivalent like fractions and then add or subtract as explained above. Example 1. Add 3 by 4 and 5 by 6. Solution: convert 3 by 4 and 5 by 6 into equivalent like fractions. LCM of 4 and 6 is equal to 12. 3 by 4 is equal to 3 into 3 by 4 into 3, which is equal to 9 by 12. 5 by 6 is equal to 5 into 2 by 6 into 2, which is equal to 10 by 12. Thus, 3 by 4 plus 5 by 6 is equal to 9 by 12 plus 10 by 12, which is equal to 9 plus 10 by 12 is equal to 19 by 12, which is equal to 1 and 7 by 12. Example 2. Subtract 5 by 7 from 9 by 5. Solution: convert 9 by 5 and 5 by 7 into equivalent like fractions. LCM of 5 and 7 is equal to 35. 9 by 5 is equal to 9 into 7 by 5 into 7, which is equal to 63 by 35. 5 by 7 is equal to 5 into 5 by 7 into 5, which is equal to 25 by 35. Thus, 9 by 5 minus 5 by 7 is equal to 63 by 35 minus 25 by 35, which is equal to 63 minus 25 by 35, which is equal to 38 by 35, which is equal to 1 and 3 by 35. Miscellaneous examples on addition and subtraction of fraction. Example 1. Simplify 2 and 1 by 3 plus 1 and 2 by 3. Solution. 2 and 1 by 3 plus 1 and 2 by 3 is equal to 7 by 3 plus 5 by 3, which is equal to 7 plus 5 by 3, which is equal to 12 by 3, which is equal to 4. Example 2. Simplify 4 by 20 plus 11 by 20 plus 1 by 20. Solution. 4 by 20 plus 11 by 20 plus 1 by 20 is equal to 4 plus 11 plus 1 by 20, which is equal to 16 by 20, which is equal to 4 by 5. Example 3. Simplify 17 by 32 minus 9 by 32. Solution. 17 by 32 minus 9 by 32 is equal to 17 minus 9 by 32, which is equal to 8 by 32, which is equal to 1 by 4. Example 4. Simplify 7 by 9 minus 2 by 3. Solution. LCM of 9 and 3 is equal to 9. So, 7 by 9 minus 2 by 3 is equal to 7 into 1 minus 2 into 3 by 9, which is equal to 7 minus 6 by 9, which is equal to 1 by 9. Example 5. Simplify 9 minus 40 by 9. Solution. 9 minus 40 by 9 is equal to 9 by 1 minus 40 by 9, which is equal to 9 into 9 minus 40 into 1 by 9, which is equal to 81 minus 40 by 9, which is equal to 41 by 9, which is equal to 4 and 5 by 9. Example 6. Fill in the box with correct fraction. 7 by 10 minus blank is equal to 3 by 10. Solution. What should be subtracted from 7 by 10 to get 3 by 10 is the same as subtracting 3 by 10 from 7 by 10. Therefore, 7 by 10 minus 3 by 10 is equal to blank. 7 minus 3 by 10 is equal to blank. 4 by 10 is equal to blank. So, 7 by 10 minus 4 by 10 is equal to 3 by 10. Example 7. Fill the blank with correct fraction. Blank plus 5 by 27 is equal to 12 by 27. Solution. We will subtract 5 by 27 from 12 by 27. Blank plus 5 by 27 is equal to 12 by 27, which is equal to 12 by 27 minus 5 by 27, which is equal to 7 by 27. Check. 7 by 27 plus 5 by 27 is equal to 12 by 27. Word problems on addition and subtraction of fractions. Example 1. Shubham painted 2 by 3 of wall space in his room. His sister Madhavi helped him and painted 1 by 3 of the wall space. How much did they paint together? Solution. Shubham painted is equal to 2 by 3. His sister painted is equal to 1 by 3. Total wall painted is equal to 2 by 3 plus 1 by 3, which is equal to 3 by 3, which is equal to 1. Together they painted 3 by 3 or whole wall. Example 2. Javed was given 5 by 7 of a basket of oranges. What fraction of oranges was left in the basket? Solution. Fraction of oranges given to Javed is equal to 5 by 7. Fraction of oranges left is equal to 1 minus 5 by 7, which is equal to 7 minus 5 by 7, which is equal to 2 by 7. 2 by 7 of oranges were left in the basket. Example 3. A piece of wire 7 by 8 meter long broke into 2 pieces. One piece was 1 by 4 meter long. How long is the other piece? Solution. Total length of wire is equal to 7 by 8 meter. Length of one piece is equal to 1 by 4 meter. Length of other piece is equal to, in the brackets, 7 by 8 minus 1 by 4, meters, which is equal to, in the brackets, 7 minus 2 by 8 meters, which is equal to 5 by 8 meters.